Let's continue on our journey of reviewing some previous topics and making sure that we have these ideas back into our brains and our active working memory. So, in number one, a diagonal walkway cuts through a park bordered by two parallel streets. The parks department plans an additional walkway shown with the dashed segment. What's the value of x? So, the key thing in here is that we want to recognize we have two parallel streets. So my street 1 and my street 2 are parallel, which means that the walkway we have in existence is our transversal. Now, seeing that my 130 degrees is an angle, I can find out what this other angle is. Recognize these are same side interior angles, so they better have a sum of 180, which would tell me that I've got 50 degrees in this angle. Now we're going to change our vision a little bit. Instead of focusing on the parallel lines now, let's look at the triangle that we have. It's a right triangle, in fact. We just found there's 50 degrees in here. So what's that x going to be? Think about how many degrees you would need in that triangle, 180, when we already have 90 and 50 taken up. So that means x must be 40 degrees. Down below here on number 2, this triangle KLM is shown on the coordinate plane. Which set of coordinate pairs then represents vertices of a triangle that are congruent to this given one? So we're going to have to try them out. So in option A, I've got a point at -3, -1, at 1, -1, and at 1, 2. So this would be my triangle for option A. Now I can see in my given triangle that I've got 1, 2, 3, 4 units across the bottom and 1, 2, 3 units vertically. So this is 1, 2, 3, 4 units across the bottom and 1, 2, 3 units vertically. Since I know that each of these triangles are a right triangle with that horizontal distance and vertical distance, that would also tell me that the hypotenuse is congruent as well, because they have to have the same measurement when you do your a squared plus b squared equals c squared. So with those 3 side lengths congruent to my 3 given side lengths, it ends up that option A has our congruent triangle. If you try out some of those other ones, and I certainly encourage you to do so, right? That B gives you 0, 0, 4, 1, and 3, 4. And so using these measurements to create a triangle, I'm even going to look at this and talk about the slope of this line that's more on the bottom. This looks like we've got a slope of positive 1/4. And then the next one to it, which looks visibly like it would be the one who has the best chance of being perpendicular, that's got a slope of -3/1. These two are not perpendicular, but my given triangle obviously had a 90-degree angle, so they were perpendicular. If I find the slope for that third side, even if it doesn't look perpendicular, maybe it's just my really bad art skills. 1, 2, 3, 4. I've got a slope then of 4/3. Again, 4/3 is not perpendicular to anything there. So without these perpendicular slopes, my triangle has not created that right angle where we would need to see it. C gives us the point at -1, 1, -4, 5, and -5, 1. So looking at this triangle, um, now it looks like across the bottom, let's see, 1, 2, 3, 4 units horizontally. So that does match up with our segment KM. But again, I wanted to have a vertical line so that I could get that right angle, and we're not quite there if I count the slopes for these, and we can visibly see that this is not going to be the perpendicular intersection that we want. The last set of points options that we had started at 1, -1, went to 6, -1, and then 6, -4. Okay, so this one does draw out with the right angle, a horizontal and a vertical line, But as we look to that, I've got 1, 2, 3, 4, 5 units across my one side and 3 units across the other. We said we only wanted 4 units and 3 units as our perpendicular measurements, so that one doesn't work either. Okay. This number 3, picking out the measurements that are going to work here for us to show the side angle side similarity. So if I take this first option here, AB compared to QR, from A to B compares with Q to R, okay, those seem to line up, right? AB is the first two, QR is the first two. Then BC to RS, okay, BC second two, RS are the second two, BC and RS, all right, I can work with those. So based on side angle side, that angle has to be in the middle. So if I want to use this proportionality for my sides, that means that my angle has to be in the middle. So I need angle B and angle R because those are the ones sandwiched in between the sides that we're talking about. Look at your answer choices. Do I have angle B congruent to angle R? That's not available to me. So I can't use these. It doesn't make any sense. I don't have the right angles available. Right? So I'll try another set. If I look here, I've got AB compared to QR. Again, AB compared to QR, and that matches first two letters with first two letters. Then AC to QS. AC is first and last. QS is first and last. Okay, so looking at these, if I want that side angle has to be in the middle. I'm talking about angle A that's formed by those two and angle Q that's formed by these two. So with these proportionalities, do I have that angle A and angle Q are congruent? Yes, we do. Angle A is congruent to angle Q, and so these are the sides that are proportional for us. That's what we're looking for. Now, number 4, whoops, excuse me as I'm having some scrolling difficulties. Okay, the diagonals of a square measure 54 inches long. So in that square, a diagonal that's 54 inches. Now remember, that square diagonal bisects the angle. So you are now talking about a 45, 45, 90. So this is x, x, and x square root of 2. So we've got to take our 54 and divide it by the square root of 2. We're not going to leave our answer like that. We're going to rationalize, multiply by a square root of 2 over a square root of 2. So we're now talking about 54 square root of 2 over 2. Don't forget to simplify your fraction. What is 54 divided by 2? That's 27 times the square root of 2. There you go, 27 square root of 2 inches. And lastly, for you to review here with this, number 5, find the values of x and y that are going to allow our triangle DOG to be congruent with triangle CAT. So remember, that congruent pattern and name is going to be so helpful for us in trying to set these items up. So I see my x's are all available as side length measurements on DOG. Please recall that there is no standard sum for side lengths in a triangle. It's only the angles that have that set sum of 180 degrees. What I have to do with my side lengths is compare it to the only other side length that I know at 26, which is segment CA. CA is the first two letters, which means it has to line up with DO, the first two letters. So if the triangles are congruent, then those individual segments are congruent. So the 3x plus 2 must be equal to the 26. Subtract my 2 from each side. 3x equals 24. And as we divide by the coefficient, x equals 8. Not so bad there. Now the other part is going to be finding the y. And I have y as a variable in triangle CAT. I also have y as a variable in triangle DOG. So I probably need to get these comparatively speaking. I do see that my y in triangle CAT comes from the C as the first letter, and if they're congruent, that's got to be congruent with the D as the first letter. So this must be the same measurement of 4y. What do we know about the angles in a triangle? They've got that sum of 180 degrees. So my 2.5y and my 4y and my 79.9 all together better be 180 degrees. So as I combine like terms, 6.5y plus 79.9 to equal 180, I'm going to subtract that 79.9 from each. So 6.5y equals 100.1. Divide by that coefficient on each. Y is 15.4. I hope that these topics are coming back into your head and you are remembering all that fabulous stuff that we learned earlier in the year.